So, hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with some unique series of electronic circuitries. You can see here I have the first one video of this series is inverter circuitry. In this series of electronic circuitry, I will go through a different electronic circuitry from basic model to advanced model as well as hardware model also. So at the end of video I will show the hardware models also, and if you want the hardware model you can get it by contacting my email id that is given in the description box. So let's get started without wasting any time or without wasting any microseconds. So what is the intention of this video? The intention of this video is when you want to make an inverter, a basic inverter, the school project, even a diploma project or B project or degree project, you can say. So this is a very simple project, and it is a just a full wave inverter. This is a just a full wave inverter. So what is inverter? What is inverter? First you need to understand what is inverter and what is rectifier. So I am explaining here what is inverter. So when you want a DC supply, what you are doing when you want a DC supply, you are using a batteries, that is a 12-volt batteries, a 14-volt battery, or batteries you are using for the DC supply. But when you want a AC supply, what you are using, the AC supply is directly available in our house. We are directly getting from the governments. Okay, so they are giving us the AC supply. So this is a difference. This is a AC supply and this is a DC supply. DC is a constant, whereas AC is a continuously varying its a magnitude. But when when the when the government supply fail, what you need to do? What you need to do? You don't have any option. You don't have any AC source. You don't even drive your fans. You cannot on your light bulbs or even your fridge, TVs. So at that moment, what we are using? We are using inverters, and this is the purpose of inverters, and this is why the inverter is most important part in our life. So what is the function of inverter? Why we are using an inverter? What is the function of inverter? So inverter, the basic concept of the inverter is it is use a battery as a supply source, and in between we have used inverters as a module, and inverter invert or change the DC supply to the particularly or very precise AC waveforms that is similar to the government that is gives to us. This is a single phase supply. I am just using a single phase. I am explaining with the single phase. There is a three phase supply also, but you don't need to focus on the three phase supply because as of now we are planning to make a single phase inverter. So now back to the Proteus. Okay, so this one is our main Proteus model. It's a very simple circuit. This is the inverter. This is a part of inverter. It's the and what is a device that we have used to make an inverter? It's a IRF540 MOSFET. Now, why we are using a MOSFET? Because MOSFETs is very capable to handling high frequency switches or with a high ampere also. So why we are using MOSFETs instead of transistors? So you can say the transistor are used for a very low voltage like a 5 voltage, 9 voltage. Yes, I know it's there is a multiple of transistor nowadays available for high voltages also, but MOSFET switching circuit and preciseness is very high, very more compared to transistors. So here what I have used or I have made a four full wave inverters or full wave inverters. So you can see here there are four different types of MOSFETs used in a peculiar patterns. So here the 12 voltage is applied, and if you want to understand very clearly, I can go with the Google also. So here it's a similar circuit. You can see here. So when current normally flows from this path to when this is operating, when this Q1 is operated, this is a switching pulse. So now you have to understood a basic function of the I know you know the basic function of the transistor. When this switching or when this gate pulse is applied, current from the source to drain. This one is a source and this one is a drain. So when this pulse is applied, whenever this pulse applied, this MOSFET gets activated and current flows from source to drain. So this is a basic concept. So here what you want to do, just I am explaining very precise way. So where there are MOSFETs. So if I am again draw the circuit like the Proteus. So what is a pattern of I am explaining very clearly. So just wait and watch. And if you don't understood the video, you can comment in the below also. So this is a battery similarly, and these are some gate pulses to the operate or to operate the MOSFET. So once okay, and here I can connect the output. Okay, so whenever these two, this one and this one, MOSFETs are get activated, currents flows from this part to this part. This is a very similar. During this time, these two remaining off. So if I am explaining, or if I am uh, draw the waveform for this current, especially for this resistive load, or I can say R. So you are getting this type of current. Okay, once in one direction, I can say this flows from this direction to this direction. Okay, now when these two gets operated and these two are in off condition, you never operate these two or these two at the same moment, because it got a short circuited. So when these two are in off condition and the remaining twos are on, so what is the path of current? Okay, यहाँ से okay, 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 like this way. So now current direction is opposite to the previous one. This one is the previous one is the now. Okay, so your current get okay like this way, change its direction. So you are getting these types of very clear waveform when you are switching this pattern. So if I am explaining you this same concepts in Proteus, you can see here uh, this similar way, and just I have connect the load as a transformer as a secondary side. Okay, on or at the output side is a load. So here I have already explained that you need a switching, and switching should be at a particular frequency. So here I have used a Arduino. In next series we will use a different different circuit of the switching. Like we can use here we can use IC555 also, or we can use operational amplifier also to switch on and off this diode. So let's get understood how these Arduinos work. So if I am trying to run it, what happen? If I am trying to run it, what happen? It's giving the error. Why it's giving the error? Because there is no hex file added. What is a hex file? When you want to drive any Arduinos, you need a program to drive it. So I have written the program. I just run it. You can see here 8 or 9 pins are defined for a specific operation. This is LED pin 1, and just I am turning off and turning on. This means I am in on off at for a particular frequency. This is a 10 millisecond, 10 millisecond. So what is the addition of the 10 millisecond or 10 millisecond? It's a 20 millisecond. So inverse of 20 millisecond, it means uh, it means f is equal to 1 upon t. So 20 milliseconds means 1 upon 20 milliseconds. So 1 upon 20 millisecond is 50 hertz. That's why I have used this pattern. 50 hertz. Why? Because all the equipments in India are working on 230 volt 50 hertz. Okay, so this is a basic concept. That's why I have used, or I have programmed like this. So I have just run it, and I got some error. Okay, Arduino board is not connected. Okay, so I have restarted the application. I think so it gets cracked, or might be something else. And just when I restarted it, it's working perfectly. This is a basic concept, or this is a basic program. Just high and low, a particular pin. There are two pins. You can see here 8 and 9, 8 and 9. So okay, this 8 and 9 pins are used to switch on the switch off two different diodes. So for these two, I have used, you can see here, 9 number pin. 9 number pin gets high, this 2 gets high, this 2 gets operated. And when this 8 number pin is high, this 2 gets operated. And this 2 pin never get high at a particular same time. That's why I have on as well as off, on as well as off, on then wait for 10 milliseconds, then on, off. Another pin on, wait for 10 milliseconds and off. So I think now you are understood the program and just the circuit also. So by the end of the circuitry, you can see here some LC components are there to filter out the or to get a proper waveform. So why we have used the LC component? So again I am explaining. If you use a simple, you are getting like this waveform. So this is not a sine wave. You are getting output like a this square waveform. What you want to, what you want like this type of wave. And if you applied this square waveform to your transformer, what is your output? What output of transformer? If you applied a primary side square waveform, what is the output of transformer? Like a spiky waveform. It's why it's a spiky waveform like this way. This is a waveform that you are getting when you are applied a square wave to your transformer, and when you are applied the sine wave to your transformer, you are getting a sine wave as a output. Why? Why this happen? Why this happen? Why you are getting a peaky wave waveforms, and why you are getting a spike at the output side of the transformer? Because transformer is a what is a principle of the transformer? Faraday's laws of electromagnetic induction. And what is the purpose of transformer? When the change in magnetic field, to drive a transformer, you need a change in magnetic field by motion or by amplitude. Here you can say there is a no change, it's a fixed. So here to here there is a one change, then it is a fixed. So when this happen, you are getting this spiky wave. And remaining time, and after the particular time and remaining time, your output is zero. Output is zero because there is a no variation, there is a no change in magnetic field. And again when this happen, you are getting some spiky waveform. And again after a particular time, there is a no change in waveform, it's a fixed. That's why you are getting a zero output. So you want to see in the Proteus, you can see this sticky waveform also. So just forgot about these components. I just removed this component and drive circuit for your checking. Okay, so you can see here there is a one transformer as output side and the load and the voltmeter. There is a nothing any LC components, and I am try to run it. Okay, so I need to upload a program. So I just run it, and once you run it, you can find the hex file here. Okay, this one is hex file. Okay, so what you need to do, you have to just copy this hex file, the path, go to Proteus, double click and go to program files. Okay, just if you have already copied the path, just remove it and paste by Control C Control V. Okay, so now your program is added in your Arduino board, and once you run it, okay, everything is as clear as crystal. Okay, so you can see the spike, here very clearly. So now just understood what is happening here. Okay, so these first two, this one is our oscilloscope, and the first two are the output. You can see high, low, high, low. At same time, there is no high at one pin. One pin is high, one another is pin low. One another pin is high, another pin is low. So at same moment, both pin are not getting high. At a particular time, one pin are getting high. So here you can see our inverter is working perfectly. But and even we are getting output also. You can see it's a spiky waveform output, and you can see very clearly your output is spiky as mentioned in, okay, it's just removed, as mentioned previously. So that's why, and your output voltage is very low. Here I have used 9 volt 12 volt to 110 and 110 volt transformer. So you can get this Proteus file in the description box, or and you will get the program also in the description box. So what you need to do, you need a proper sine wave, and that's why what you need to use, these components. So how you can calculate this value? There are multiple of method. I have used trial and error method, or one calculation is also there. So I will also explain or you can say you can follow this calculation. I will uh, the calculation that is available on the screen. You can follow this calculation, and you will get this value. So after connecting it, what your output? Okay, what is a hex file? Okay, I need to okay, redo कर. Okay, so because I have undo more time. Okay, and I need to again add the program. And once I started, you can see very clearly your output is 110 to 120 volt nearly, and that is very fixed and a very crystal clear waveform. This is spiky due to some capacitance and inductance behavior, and you can see you can easily get 110 volt, and with this voltage you can easily turn on a LED bulb for 9 volt 12 volt, but you can easily turn on the LED bulb. So this is your output of your inverter pin. This is a primary. This one is your primary input, and this one is your final output. It's a very crystal clear. Okay. So I have just made a hardware circuit. Also, I am explaining the hardware circuit. So when I made it, so here you can see this is a battery. It's a very Duracell 9 volt battery. I have just used a 9 volt battery, and these are MOSFETs IRF540 Arduinos for switching on and off. And I have just used two capacitors of 100 microfarad at 25 volts. Two capacitor connected in the parallel. So what is your final in parallel? It's these two capacitors are connected in parallel, so 100 microfarad. So addition of these two is 200 microfarad capacitors adding, but 25 volt. Okay, and I had not connected any on, and in this video you can see very clearly. uh, okay, these are the capacitors, and this is our transformer 9 volt to 110 volt transformer. And when I run this video, okay, you can see when I run this video, this is a bulb that is connected as the output side of the transformer, and one is the input side that is connected with this circuitry, and this is a voltmeter. You can see the voltage levels also. It takes some time to increase the voltage level because the capacitor gets charged and discharged, and according to that your output is getting high. You can see here the bulbs are getting on when your voltage reaches to nearly 60 volt. So by this way you can make an inverter. If you want this inverter circuit, you can you if you want this hardware circuit, you can contact with me, that is given in the description box. I have given my email ID. You can contact through my email ID, or you will get the Proteus simulation also in the description box. So this is how you can make a very simple inverter without using or without it's a very cost effective also. There is no any major electronics component, no any complex circuitries, just the inverter and just a transformer and LC component, and Arduinos is also there. Even I am working on IC555 and MOSFETs, IC555 and operational amplifier to switch on these MOSFETs. So this video you will get after this video series, or next videos will be on the IC555 and MOSFETs. So this is a very simple video and very understandable video. Uh, you can see your bulbs are getting on, and glow is very high, and you can make this project for your final. Okay, so I hope you like this video and enjoy this video. Thanks for watching this video. If you have any query, just contact me through description box or through comment box also. So again, thanks for watching this video.